So in this video, we are going to cover all of the equations prerequisite knowledge required for a calculus-based course. So this comes up in the Year 11 Maths Advanced course in New South Wales. So using this video will give you just a good idea of all of the things maybe you need to revise that will basically come up in this course. Like with the algebra we covered in the previous video, it's really important to be quite up to date on all of the equations knowledge, things like the quadratic formula, completing the square, as well as just solving regular equations will serve as the foundation for a lot of the things we will be doing later on in this series. So talking about equations, we are solving linear equations. So here, we just want to get everything on one side. So we want the pronumerals on one side and everything else on the other. So I'm going to subtract 4x from both sides here, giving me 2x. And I'm going to subtract 5 from both sides, giving me negative 14. And once I divide both sides by 2, this gives me minus 7 over here. Now this one on the right-hand side, we have 4x minus 7 on the denominator. We want to get it onto the other side first. So we multiply both sides by 4x minus 7. So this first side becomes 4 minus 7x, the numerator, and then 4x minus 7 goes on the other side. We can add the 7x to the other side. That gives us 11x. And then we can add the 7 to the other one also, which gives us 11. So here, x is going to equal to 1. Now in the next one, we are looking at changing the subject of a formula. So changing the subject of a formula just means getting one thing on one side with everything else on the other side. So currently, this first example, y is the subject of the formula. We want to make x the subject of the formula. So we want to get everything else away from the x here. So first we can add the 3, which gives us y plus 3 equals 4x. And then we can divide both sides by 4. So I get y plus 3 over 4 equals x. Now x is the subject of the equation. So for my next one, I want to rearrange this equation. I want to make x the subject. So I'm going to multiply the denominator across first. So I'm going to get y multiplied by x plus 2 equals to x plus 1. Now I'm going to expand the brackets on the left-hand side. So I get xy plus 2y equals to x plus 1. Now I want to get the x's together and the y on the other side. So here I'm going to subtract the x from both sides here. So I get xy minus x, and I'm going to subtract the 2y from both sides. I'm just doing this all in one go because this is assumed knowledge. I'm moving everything to one side. Then I want to factor out the x on this left-hand side. So it goes into xy, y times, it goes into negative x, negative 1 times. The right-hand side stays the same. And to get x on its own, I want to divide both sides by y minus 1. So I get 1 minus 2y over y minus 1. And I have now made x the subject of the formula. Moving on, we're talking about solving quadratic equations. So we're going to do this in a couple of ways. This first way, we are going to do this just by our factorizing. So here we have a non-monic quadratic. So we're going to use our PSF method that we've talked about many times previously. But when it's non-monic, our product is the coefficient of x squared multiplied by that constant term at the end. So we want two numbers that multiply to give negative 35 and add to give 34. So those two factors, I have positive 35 and negative 1. Now, in order to factorize this, I can now rewrite this as 5x squared plus 35x minus x minus 7 equals to 0. Now, factoring out, remember, we want to do this grouping in pairs that we talked about in the previous video. So we pull 5 out the front, 5x, sorry, because that goes into both of these. I'm left with x in the bracket plus 7. And in the other one, I'm going to pull out negative 1. And that gives me x plus 7 in the other one equals to 0. Now I have a common factor of x plus 7 in both. So I'm going to pull that out the front, x plus 7. And in the other bracket, I'm going to get 5x minus 1 equals to 0. And now we want to actually solve this quadratic equation. So remember, here we're going to use the null factor law. So we are saying that this is a binomial product now. So these two are multiplying. That's like this assumed kind of hidden operation here. Now, the only way to get a answer of 0 for a product of two numbers is for either one of those or both to be 0. So we have two possible solutions to this equation. We have one option, which is x plus 7 equals 0. And we have another option that 5x minus 1 equals 0. So now all we want to do is we want to just solve these two mini equations. So the first solution is going to be x equals to negative 7. And the second one, we add 1 to both sides and we divide by 5. So x is going to equal to 1 over 5. These are our two solutions for this first one. Now with the second one, we are going to be solving this when we can't apply our factorization like we've done before. We need other methods. Now there's two we're going to talk about in this video. This first one that we're going to do is the quadratic formula. So I'm going to write this in, but this will come up on your formula sheets once you sit an advanced maths exam. But I'm going to rewrite it here for you. So minus b equals plus or minus the square root of b squared minus 4ac all over 2a. So we can substitute into this formula to just get our solutions right off the bat. Now our a term is the coefficient of x squared, our b term is the coefficient of x, and our c term is the constant at the end. So here, we just want to substitute this in. I'm going to get here one of the options. If I just substitute into the b squared minus 4ac, I'll just do that because that's a bit easier. Now if I substitute a being positive 3, b being positive 4, c being negative 1, you're going to get 4 squared plus 12 when you multiply these through together. So this is going to give us, so 16 plus 12 gives us 28. And we're going to write this in. So my two solutions, I have x equals to minus b, which is minus 4. One of them is going to be minus 4 plus the square root of 28 on top of 2a, which is 2 times 3, that gives us 6, or minus 4 minus root 28 over 6. Now we can actually simplify this further with our simplification of surds. So in this root 28, I can pull out 4 and simplify this surd. So I get minus 4 plus, and I'm going to split this root 28 up into root 4 times root 7. Now the square root of 4 is just 2, so I can write this as 2 root 7 over 6, and the same thing on the other one. So minus 4 minus 2 root 7 over 6. Now this can actually be simplified even further. I can just take out a common factor of 2 from this, and the bottom one. So since I'm running out of space, I'm just going to rewrite this fully simplified, but we will go over this when we do surds in the next video. But this will simplify down to minus 2 plus root 7 over 3, or minus 2 minus root 7 over 3. So a question will typically say in the simplest exact form, this is how that's going to look. Now we've solved this given the two solutions in simplest exact form. Now the next part, we are talking about solving simultaneous equations. So I've got two here. These are non-linear simultaneous equations because we've talked a lot about linear ones previously. So I'm going to do these two, one using substitution, one using elimination. Now, when we substitute, it requires us substituting one part of the equation in for the other. Now here, I can substitute equation 1 into equation 2 because both of these y's are the same. So we can make this substitution to put x squared in place of the y in equation 2. So what I'm going to write down is I'm going to sub equation 1 into equation 2. So I get x squared equals to x plus 2. And I can move everything to one side because I can see this is going to be a quadratic equation. So I get x squared minus x minus 2 equals to 0. So I can factorize this out. Two numbers that multiply to give -2, add to give -1. I'm going to get x minus 2, and then x plus 1 equals to 0. So my two solutions here are x equals +2 or -1. Now remember, because we have two x solutions, we have two y solutions as well. So I'm going to substitute in these back into one of the two equations. And we always want to go for the path of least resistance. In this case, both of these will be roughly kind of similar, but I'm just going to substitute it into equation 1. So I'm going to sub into equation 1. So one of them is going to be that y equals 2 squared, which gives 4, and y equals -1 squared, which equals to +1. So my two solutions are x equals 2 and y equals 4. That's one solution. The other one is, we can write or x equals -1, y equals +1. So the second one, we are going to do this using elimination. So remember, with elimination, we want to add or subtract one of the variables in order to eliminate them. So we want to subtract an equation from the other or add the two equations together. That will eliminate one variable entirely. And this only works when the coefficient of one of the variables is the same. Now you can see there's two ways we can go about this. We can either minus the two equations to get rid of the x squared, or we can add the two equations to get rid of the y squared. Now I'm going to add the two equations. So I'm going to say equation 1 plus equation 2. The two y's are going to cancel out. So adding these, it's going to give me 2x squared. The y's cancel out, equals to 98. Simplifying this, I divide both sides by 2, giving me x squared equals to 49. And that's going to give me x equals plus or minus 7. Now I can substitute either of these back in. So I'm going to substitute +7 or -7 into one of these. Now, the rest is just substituting in and basically computation. So I'll leave you, you can pause the video, practice subbing it back in because we have done this a lot previously. I'm going to go straight into the answers because there's a decent amount to get through. When x equals +7, y equals -2. And when x equals -7, y equals to -2. So y equals to +2. Okay, moving on. We are looking at completing the square. So here, we remember this process where in order to complete the square, we took the coefficient of the t term or the x term, because remember, we are thinking in terms of the coefficient of t squared being a, the coefficient of t in this case being b, and then the constant being c. We need to halve the b term and then square it. But then we have to take it away to compensate for adding that new number in. So basically, what we're going to do here is I'm going to get t squared plus, and I have 8t plus 8/2 squared. And if I've added that to one side, I'm going to add that same thing to the other side. So what we do to one side of an equation, we have to do to the other as well. Or you can add it on this one and then take it away. Or it's just easier just to add it to both because an equation has to be balanced, right? So what we do to one side, we have to do to the other as well. So what I get left with is I have t squared plus 8t plus 16 equals to 20 plus 16 gives 36. So I can factorize this left-hand side because when we complete a square, it will always give us a perfect square. So here I get t plus 4 squared equals to 36. And when I square root this, I can get t plus 4 equals plus or minus 6. So I have two options. So I can either have t plus 4 equals 6 on this left-hand side. So the solution here would be t equals to 2. Or t plus 4 equals negative 6. So this second solution is going to be t equals to negative 10. And we're going to do the exact same thing on this side. So we have x squared minus x. And now remember, to complete the square, we have to take this coefficient of x, our b term, halve it, and then add it. So what I'm going to do is I'm going to add negative 1 over 2 squared. And now because I've added it, in this case, because everything's all on the one side, I'm going to undo what I've just done. Because I can't just pull this out of thin air and add it. I have to make something that's equivalent to this top line. So that means that if I add it, I have to take it away again. So it basically cancels it out so that I get something equivalent. So what I end up getting is, once I clean this up, I get x squared minus x plus 1 over 4. And I'm going to compute this and then bring it over to the other side. So this will give me negative 1 over 4, negative 1 and a quarter, I should say. And then I'm just going to add it to the other side. So that gives us 1 and a quarter, or 5 over 4. And now I want to factorize this perfect square. So it's always going to become a perfect square. This is going to factorize down to x minus a half squared equals to 5 over 4. And then I'm going to square root both sides. So I get x minus a half equals to, so if I square root 1 over 4, it gives me a half multiplied by root 5. That's the numerator over here. And I get positive or negative, so I get plus or minus. Now, one option is for x minus a half to equal a half root 5, or x minus a half to equal negative half root 5. And once I add the half to both sides, one solution in exact form is going to be a half plus either root 5 on 2 or plus a half multiplied by root 5, or x equals to a half minus a half root 5. Okay, so this brings us to all of the end of basically all the concepts that will be prerequisite knowledge. So if there was anything from this that kind of threw you off, something to look back on, because these will all come up in various forms when we go into the Maths Advanced course from year 11. So making sure you're all up to date with these ones. This is basically a summary of every part of equations that we've done up to now, which is going to be our assumed knowledge for a calculus-based course. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.